When we're working with absolute values, remember absolute value means distance from 0. And we have, like if I said what's the absolute value of x, but the absolute value of x equals 5. And that means what's inside the absolute value symbols could be a positive 5 or a negative 5. Because would you agree that positive 5 and negative 5 are both 5 units away from 0? Yeah. So what that should tell you is when you're dealing with absolute values, how many solutions are you going to have? 2. You have 2. Okay. So when you're solving equations with absolute values, the first thing you have to do is isolate the absolute value. In other words, get the absolute value by itself. So we need to subtract 9 first. This is going to get the absolute value by itself. And that gives me, what, 11. So the absolute value equals 11. So what's inside the absolute value symbols could equal positive 11. Or what's inside the absolute value symbols could potentially equal negative 11. So this gives me 2 mini equations to solve. So on both of them, I just have to subtract 8 from both sides. And that's going to give me, what, 3 or negative 19. So I have 2 answers. The nice thing is you can always check your work. If I plug in 3 back into my original, I get 3 plus 8 is 11. Absolute value of 11 is 11. Plus 9 is 20. So that one checks out. If I plug in negative 19, negative 19 plus 8, negative 11. The absolute value of that is positive 11. Plus 9 is 20. So they both check. So we have 2 answers, 3 and negative 19. The key is to remember that you have to isolate it first before you split it. Okay?
Don't you put them in the computer as like parentheses?
Actually, for these in the with absolute values and you're doing equations, it'll probably just say separate with a comma. Yeah, type an integer or simplified fraction, use a comma to separate answers. They've already got kind of these squiggly bars in there already, so you just have to type 3 comma negative 19. Okay? Number 12 says find the distance between the given points on a number line. So 25 and 17. Absolute value deals with distance, and so that's why I'm just following up our last problem with this. This is probably the easiest problem on the test, and some people tend to miss it. They'll put a negative. So remember when you're finding distance just between 2 points like this, it really truly is just a subtraction problem. 25 minus 17 is 8. Now, I will tell you what could potentially happen on your test. What if they gave you the numbers in reverse order and said, find the distance between 17 and 25? I always have students that go, oh, well, I just subtract. That gives me negative 8. This is a distance problem. You cannot be negative 8 away from anything. Okay? So that's where the absolute values come in, because you're thinking, how is this an absolute value problem? Whenever you're dealing with distance, just make sure that you put it in absolute value symbols, and then it becomes positive 8, and then you don't have anything to worry about. So yeah, number 12 is 8. 17 says graph and write the solution in interval notation. And so we have x is less than 6 and x is greater than or equal to negative 3. Now we don't have to solve anything here. So we just have to graph it and put an interval notation. If they gave me 2 inequalities to solve, I would solve them first, and this would be like my answers. But this problem, we don't have to do any solving. So if I graph this, and I'm just going to draw a number line. I'm dealing with the number 6 and the number negative 3. So I'm going to put negative 3 down here, 6 will be up here somewhere. I need to be less than 6. So less than 6 is an open parenthesis opening to the left. And I need to be greater than or equal to -3. Well, that's a squared off bracket opening to the right, which means all of my answers are the ones that fall in between. So the squared off bracket, because it can be equal to -3 or greater, so to the right. And then the parenthesis, because it has to be less than 6. It can't equal 6. It's less than 6. So that's my graph. And then interval notation looks a lot like the graph. So if they ever say solve and write in interval notation and they don't make you graph, you can still graph. I still graph because it helps me set up my interval notation. Interval notation, if I've got a bracket on the left, I'm going to have, on my graph, I'm going to have a bracket on the left of my interval notation. If I've got a parenthesis on the right of my graph, I've got a parenthesis on the right of my interval notation. All interval notation is what's the lowest it can be, what's the highest it can be. Well, it can be all the way down to -3, so the lowest is on the left, comma, the highest is on the right, 6. So you might look at that and go, oh, that's an ordered pair. No, it's not an ordered pair. Okay, it's interval notation. The lowest it can be, the highest it can be. I have a squared off bracket indicating it can equal -3. And I have a parenthesis next to the 6 because it cannot equal 6, but it can be less than 6. So that's my interval notation. So 25 says solve then graph. So this is a real easy solve. I just have to add 6 to both sides. That leaves me y greater than, was that -7? And then we have to graph it. The graph, is it a parenthesis or a bracket? Parenthesis because it's not equal to, so it's just an open parenthesis to the right, and then we would shade to the right. So looks like option 25. We want the parenthesis one, so it'd be D. Yeah, option D. And now let's look at number 10 because it actually is a compound inequality. It's got 2 inequalities that we have to solve and graph. So the first one, we have 6x plus 3 is greater than or equal to -33, or 8x plus 1 is greater than or equal to -15. Now I'm going to solve these completely separate first, which I have to do anyway, and I'm actually going to graph them separate, and then we'll put them on the same graph and see what it looks like. So we solve inequalities the same way we solve equations. We just got to get at the x by itself. The only thing you have to remember is if you have to multiply or divide by a negative in the end, then you have to reverse your symbol. But I don't think we'll have to do that in this problem. So that's going to leave me x greater than or equal to -6. Let me do this one real quick. Ooh, I'm glad they didn't come out to be fractions. Okay. So let's see here. I've got -6, -2, and I'm going to throw 0 on here just for some perspective. Okay. So I'm going to graph them individually first. If I want greater than or equal to -6, let me change my color. Greater than or equal to -6 would be a bracket opening to the right, and I would shade that direction. If I want to graph the other one, it would be greater than or equal to -2. So I would have a squared off bracket at -2, also shaded to the right. So they're both going in the same direction. This is where the word comes into play. Because if the word is or, it's one way. If the word is and, it's a different way. And the reason for that is if I am this or this, which numbers fill that criteria? Yeah, this one. Because you can be anywhere in the red and you're fulfilling this or that. But if the word was and, it would only be in the green. Because these are the numbers that fit both criteria at the same time. So that's where that word comes into play. Most of the time, the or compounding qualities, they actually go in opposite directions. So we never have to think about it. Because it goes that way or that way. Because that will never be an and. If you graph it and you've got this direction and you've got white space in between, and the word is and, you can't be over there and over there at the same time. So that would be no answer, no solution, nothing shaded. But if it's or, yeah, you can be there or there. So yeah, this word really does make a difference on this problem. If it's this or this, then the graph would be anything in the red. If it's and, then it's anything in the green, because it can be this, it has to be this and this at the same time. So that word is really important. All right, so we have an absolute value inequality. How does that work? Whew. So, first of all, we are going to have two separate answers. Okay, this will be a compound inequality. So my first problem is the first part that we have to do is make sure my absolute value is isolated, and it is. There's nothing else on the same side as the absolute value. So I can go ahead and split it. So 2x minus 9 is less than or equal to 18. And then the other part of this is going to be 2x minus 9 greater than or equal to negative 18. And I know we're going to have to stop and talk about that. Because remember when we did the equation and we said what was inside could be the positive or what's inside could be the negative? You're probably okay with that. But why are we switching the sign? Because of the absolute value. And if you think about absolute value and the number line. So if we are, let's say just the absolute value is less than or equal to 18. Well, if you have a number line, I'll just sketch one towards the bottom here. I can always erase it later. Okay. Let's say I have 0 in the middle. And let's say I've got 18 and I have negative 18. If my absolute value is getting or is less than or equal to 18, that means I'm getting closer and closer to 0 because it's distance less than or equal to 18, so I'm getting closer and closer and closer and closer. Okay, it's kind of like if you're downtown and you're like at Town East or Town West. Okay, they're not, the same exact distance, but I think you understand where I'm going with this. So, I mean, you're just getting close. If you're at one or the other, like if you're at Town East and I'm at Town West and we both start driving, we headed towards downtown. Okay, that's kind of the scenario that we've got going on here. So, the way it works on a number line is if I'm less than or equal to 18, I'm getting closer and closer to downtown, then on this end, I have to be greater than or equal to in order to keep going towards downtown. Otherwise, I'm headed to Goddard. Okay? So that's why the switch for the signs as well. So the way I remember it is I write it once, the way I see it, just drop my absolute value symbols, and then I rewrite it, and then reverse my sign and opposite my number. It's kind of like a leave change opposite, but with inequalities. Now I can solve them both individually. So I would have to add 9 to both sides. That's going to give me 2x less than or equal to, I'm starting to go brain dead, 27, divide by 2. Oh no, fractions. That's okay. Does the direction specify fraction? It does say type an integer or fraction. So we would have to make sure that we typed 27 twelfths. I'm sorry, 27 over 2. What number are we on? 16. So I have x is less than or equal to 27 over 2. And then when I solve this one, I'm probably going to get a fraction again. So that's what, negative 9? Yep, I do. So I get x is greater than or equal to negative 9 halves. And when I look at the problem, they actually just give me 2 boxes to plug my numbers into, and they're writing it all as one sentence. So you might go, well, which one do I put in which box? How do you know which one goes where? Just remember, yeah, the negative one on the left and the positive one on the right. And if you look, try to match up your signs. If you want, it says we have x less than or equal to 27 halves. So you want the 27 halves to go in the box on the right, because then it would read x less than or equal to 27 halves. And then put your negative 9 halves in the other box. So yeah, just pay attention to your signs on that one.